Compound interest is an exponential function, whereas simple interest was a linear function. In compound interest, F stands for future value in dollars, P stands for principal value in dollars, I is the interest rate per period, which will be the overall interest rate divided by the number of periods per year, and N is the number of compounding periods, which is the number of years times the periods per year. So compound interest follows the formula F equals P times 1 plus I to the N. Example 1, find the future value of an account with initial deposit of $1,000, compounded quarterly at 4% interest after 3 years. So $1,000 is the principal amount, and we want to find F, the future amount. Compounded quarterly means 4 times per year. So there are 4 periods each year, and the rate is 4%, or 0.04, and the number of years, or the time in years, is 3. So using this information, we want to find I and N. So I is going to be the interest rate per period, or the rate R divided by the number of periods per year. So since the rate R is 0.04, we take that rate and we divide by the number of times per year, which is 4. So we divide 0.04 by 4 to get I equals 0.01. Now we find N. N is the number of compounding periods total, which is the number of years multiplied by the periods per year. So the number of years is 3. We multiply that by the number of periods per year, which is 4, to get N equals 12. Then we have all of the components that are needed for the compound interest formula. So F is equal to the principal amount, which was 1,000, multiplied by 1 plus I, which was 0.01, raised to the N, which is 12. This gives a future value of approximately $1,126.83. So we can see that as opposed to simple interest, compound interest is exponential because the number of compounding periods N is in the exponent. Example 2, find the future value of an account with initial deposit of $5,000 after 10 years with interest rate 1.5%, compounded semi-annually. So in this situation, the principal value is 5,000, and we want to find the future value. So let's next find I. I is the interest rate per period. The rate overall is 1.5%, which is 0.015. Compounded semi-annually means twice per year. So the rate is, or the interest rate I is 0.015, or the R, divided by the number of times per year, so divided by 2, which is 0.0075. We also need N, the number of compounding periods, which is the number of years, which is 10, multiplied by the number of times compounded per year, which again is 2. So the number of compounding periods is 20. Now plugging into the formula, we get F equals the principal P, which is 5,000, multiplied by 1 plus I, which is 0.0075, raised to the power n, which is 20. Which is approximately 5,805.92 cents. Example 3, find the interest rate for a deposit of 7,500 accumulated to 12,001 over 6 years with interest compounded annually. Now, interest compounded annually means just one time per year. So in this situation, we can actually use the equation F equals P times 1 plus R to the T, where T is the number of years. Because the compounded annually means just one time per year, so the number of years is equal to the number of times that the interest will be compounded. So in this example, we want to find the interest rate R for the deposit. And we know F and P. So P is the principal, 7,500. F is the future amount of the account, which is 12,001. And we also know T, which is the number of years, which is 6. Plugging in that information, we get 12,001 equals the principal amount, 7,500, multiplied by 1 plus R, to the T, which is 6. And now we solve this equation for R. To solve for R, we first divide by 7,500 on both sides. You can leave 12,001 over 7,500 as a fraction, or you can round it to a decimal. I recommend leaving it as a fraction. It comes out to 1.60013. So you could use that decimal, or we can just leave it as a fraction. 12,001 over 7,500 is equal to 1 plus R to the 6th power. So now to solve for R, we want to multiply by 1 over 6 in the exponent, or take the 6th root of both sides. So if we multiply by 1 over 6, or take the 6th root of both sides, we would get 1,201, or 12,001, divided by 7,500 to the 1/6 power is equal to 1 plus R. And calculating this gives 1.0815 equals 1 plus R. So last step to solve for R is to subtract 1 from both sides, which gives 0.0815 equal to R. I wrote equals, but actually this is an approximation because it is rounded, so I'm going to write approximately. So the rate, if we switch it now back to a percentage, is approximately 8.15%. Because to get the rate R from the percentage, we divide by 100. So to get the percentage from the decimal rate, we would multiply by 100.